Good morning, 8th graders. We are on lesson 3 on our chapter on waves. So let's go right to our My Planet diary. We're looking at disaster. So it's called The Fall of Galloping Gertie. My breath was coming in gasps. My knees were raw and bleeding. My hands bruised and swollen. Safely back at the toll plaza, I saw the bridge in its final collapse and saw my car plunge into the Narrows. This dramatic piece of writing is a witness's real-life account of the collapse of the Tacoma Narrows Bridge in Tacoma, Washington on November 7, 1940. Prior to its collapse, the suspension bridge was known for its swaying and rolling in the wind. This motion happened so regularly that the bridge was nicknamed Galloping Gertie. Only 4 months after its construction, the bridge collapsed into the waters of Puget Sound during a windstorm. Although a disaster, Galloping Gertie's collapse became a valuable teaching tool for engineers. So if you were an engineer studying this bridge collapse, what is one thing you would research? One thing to think about is researching other bridges that are in really windy areas, such as Chicago, usually called the Windy City. There are some bridges there. So you could research how those ones are built and what you could do differently to help make them stronger. So 3 key questions today. What changes the direction of a wave? What are the 2 types of wave interference? And how do standing waves form? So waves change direction by 3 things: reflection, refraction, and diffraction. Those are 3 big things you're going to want to remember for your assignment. So reflection is the bouncing back of a wave when it hits a surface through which it cannot pass. Refraction is bending of waves due to a change in speed. And then bending occurs because different parts of the wave travel at different speeds. However, waves do not always bend when entering a new medium. No bending occurs if a wave enters a new medium at a right angle. Bending does not occur if the speed of the wave in the new medium is the same as the speed in the old medium. And then diffraction is the bending or spreading of waves as they move around a barrier or pass through an opening. Interference is the interaction between waves that meet, and there are 2 types of interference: constructive and destructive. Constructive interference is interference in which waves combine to form a wave with a larger amplitude than any individual wave's amplitude, and helping each other or adding their energies together, basically. Okay? And destructive interference is interference in which 2 waves combine to form a wave with a smaller amplitude than either original wave had. And our last key question answer: if the incoming wave and reflected wave have just the right frequency, they combine to form a wave that appears to stand still. This wave is called a standing wave. So a standing wave is a wave that appears to stand in one place, even though it is 2 waves interfering as they pass through each other. So not actually standing still, it just looks like it. A node in a standing wave, destructive interference, produces points with 0 amplitude, and an antinode is points of maximum amplitude on a standing wave. So most objects have at least one natural frequency of vibration. Standing waves occur in an object when it vibrates at a natural frequency. And then resonance is an increase in the amplitude of a vibration that occurs when external vibrations match an object's natural frequency. So our vocabulary for today: reflection, the bouncing back of a wave when it hits a surface through which it cannot pass. Refraction is the bending of waves due to a change in speed. Diffraction, the bending or spreading of waves as they move around a barrier or pass through an opening. Interference, the interaction between waves that meet. Constructive interference is interference in which waves combine to form a wave with a larger amplitude than any individual wave's amplitude. Destructive interference is interference in which 2 waves combine to form a wave with a smaller amplitude than either original wave had. A standing wave is a wave that appears to stand in one place, even though it is 2 waves interfering as they pass through each other. A node is in a standing wave. Destructive interference produces points with zero amplitude. Antinodes are points of maximum amplitude on a standing wave. And resonance is an increase in the amplitude of a vibration that occurs when external vibrations match an object's natural frequency. So finally, your assignment, complete the questions on Edmodo for lesson 3. If you have questions, let me know. Otherwise, have a great Thursday.